Like that was. Why are you talking about me?
Yeah. Anyone else need one? Pencil? Nothing? Okay, just to get us in the right frame of mind for today, does everyone know how to play Uno, the card game?
Yes.
The card. Okay, so we're starting with the blue 5. We want to get to a green 9 using those 4 cards. Okay, so in a proof, where do you always start? Given. All right, and our reason is? Given. Where do we go next? Why blue 3? Same color. Then where would we go? Red 3, why? Same number. Then where? Red 4, why? Same color. Then what? Green 4, why? And then what can we end with? Same color. So do you see that everything you did had a reason? Right? You just didn't do it because of willy-nilly, right? Okay, let's try another one. We're given these cards. We want to get to a red 6. So where do we start? So there's our 1. Then where do we go?
Blue 0.
Blue 0. Then where?
Blue 9.
Blue 9.
Green 9. Green 6.
Did we get there? Pretty good. Okay, good. Let's do one more. What do you guys think? Yellow? Okay.
Then blue 2.
Then blue 2?
No.
Green.
Which one, blue or green?
Green.
Oh my gosh, guys, you're
Blue. Then where?
8.
And then we finish? Did we have to go in that order on this one?
No.
Could we have gone to the... Which could we have done first?
Blue 8.
The green 2? Should we do one more?
Sure.
Let's do one more. What's a surprise? Ooh, a wild. Okay, we're starting with a red 2. Now where are we going?
The wild.
Wild for what?
Blue. Green.
Are we going green?
No.
Yeah. Okay, now where are we going?
Green 4.
Green 8.
Blue 8.
Blue 8. Very good. Very good. So it was pretty easy to figure out your destination, right? Because you've played Uno. And then when we were doing our algebraic proofs, how long have you guys been solving equations for? Long time. So it's like if you know how to do it like subconsciously, right? Today I'm asking you to make a segment proof. How long have you been doing geometry? 9 weeks. So how much background knowledge do you have? 9 weeks. Pretty small chunk, right? So today you're probably going to be confused. You're probably going to walk out of here feeling not great with your homework. But just know by tomorrow you'll understand more of what to do. So just know you're probably going to be lost, and it's okay because everyone's going to be lost. All right? But you're just being a detective today. So while you're being a detective, we have to kind of figure out our reasons, like same color, same number, like we were doing with Uno. So that's what we're going to work on first. So are you guys all open to this page, this segment proof reference page? Okay, we already know these ones, adding, subtracting, multiply, divide. We've used those before. But now we got to talk about these other ones. The word reflexive, what does it look like? What does the word reflexive look like? Reflection. So think of it that way. The same thing is equal to itself. So segment AB is congruent to segment AB. That's the reflexive property of congruence. The same thing is equal to itself. You guys know what symmetric means?
Same on both sides.
Same on both sides. Yeah, think of like a butterfly. So if segment AB is congruent to segment CD, we can flip the order. Then segment CD is congruent to segment AB. That's a symmetric property. You just flip the order. Now the transitive property says if segment AB is congruent to segment CD and segment CD is congruent to segment EF, what two things would be equal?
A, B.
A, B, and E, F.
Yeah, because they're equal to the same thing, right? That's the transitive property. These ones are easy to kind of confuse or distinguish, so why don't you go like this? Reflexive property is the same thing. Symmetric property deals with two different things. And the transitive property deals with three different things. And that might help you later on when you're trying to decide which one is being used or not, okay? So you'll use these quite a bit. Let's see what's next here. Definition of congruence, we've talked about that informally before, right? So that just says if you have congruent segments, then their measures are the same. Or if you have the same measures, then those segments are congruent. You're just either taking away or adding those segment bars. That's all that means. If you have congruent segments, then their measures are the same. Or if their measures are the same, then they are congruent. If I had this picture here and I'm told that M's the midpoint, what do you guys know? If M's the midpoint.
A equals MB.
Beautiful. That's definition of a midpoint. Maybe draw that picture on the side since you have the space to, just so you know what it looks like. So if M is the midpoint of AB, then you guys know that AM equals MB. Segment addition, we talked about this, I know, a long time ago, like a couple weeks ago. Now, remember, all the segment addition is your whole segment is equal to the two parts that make it up, right? So AB plus BC is equal to the whole thing. That's the segment addition. So I realized I just threw a ton of information at you and didn't even let you really absorb it. And I apologize. That's just kind of how it works sometimes. But now we're gonna play detective. They're gonna give us a statement like this, and we have to decide what kind of property it is. Okay? So you're just kind of deciphering through information right now, okay? So we're given a statement and we have to figure out what property, theorem, or postulate it is talking about, okay? So here we go. If PQ equals PQ, then segment PQ is congruent to segment PQ. What property? Definition of congruence, right? What happened from here to here? We just put the little bar on top, right? That's definition of congruence. And you can abbreviate enough to where you can still make sense of it, right? Definition of congruence, but you can't do it so little that no one knows what you're talking about. But as long as you make it still what it is, that's okay. You guys want to work across or go down?
Cross.
Across. If K is between J and L, then JK plus KL equals JL. Refer to midpoint or segment addition. Maybe draw a picture. Right? JKL. What do you guys think?
Definition of midpoint.
Does it say it's the midpoint though?
Postulate.
Yeah, this one's segment addition. We aren't told it's the midpoint. Segment addition. segment EF is congruent to segment EF. Yeah, right, it's the same thing, equal to itself. That's the reflexive property. And since it does have that congruent symbol, technically you should put it, but if you just put the reflexive property, I'm okay with that. If RS equals TU, then RS plus XY equals TU plus XY. Right? So break it down. This is what you started with. How did we get to here? What's different from the purple to the green? What's different in those equations?
You're adding XY.
What did we add? So if we added something, that's just the addition property? Think of it as a number. Think we just like added 5 to both sides. So that's the addition property of equality. If AB equals DE, then DE equals AB. What happened there? Flip flop. Which one's that?
That's the symmetric.
Symmetric. You just flip flop. And since they have an equal sign, technically we should put it, but again, if y is the midpoint of segment xz, then xy equals yz. Yeah, and sometimes you guys, it kind of tells you if it's given though, if it's using the word midpoint, it's probably definition of a midpoint. So we're going to basically copy that same process, but now in a proof. So really, they're giving you the reasons or the statements, and you just have to find the reason. So again, you're just seeing what's different from each line, but now they're going to format it in a 2-column proof, okay? So we'll kind of see what this looks like. Is this what your first one is? Does this match your first proof on there? Okay. So let's just see what they give us. It says E is the midpoint of DF. So if I just look at my picture, and if E is the midpoint, what do I already know?
They're equal.
What's equal?
Yeah.
I'd probably put that right here. DE equals E. Like your little brainstorm, or mark it on your picture. Do something so you know that E is the middle, or that those measures are the same. And that's like your brainstorm, okay? Or don't forget that that picture is there. Today, earlier, kids are like, oh, I forgot there was a picture. It's kind of hard to do the proof if you're not even looking at your example. Okay, let's see how this goes, folks. Why is E the midpoint of segment DF? Because it's given. That's your freebie. Write it down. Why can we say DE is equal to EF?
E is the midpoint.
Because it's the midpoint, so you're going to say definition of a...
Midpoint.
Okay, good. Again, you can abbreviate, but just make sure there's enough there so I know what you're talking about. Okay, so now we're going to be a detective from 2 to 3. What's happening from line 2 to 3 in our equation? What's different?
You're adding to addition property.
What did we add to both sides?
D.
You guys see that? We added DE to both sides. So the addition property. Okay, again, detective work. What happened from 3 to 4? It's kind of weird.
It's the same exact thing, isn't it?
Right.
It's like symmetric.
What happened right here? What did we do to those two? Combine like terms, simplify. Either of those work. Whatever your heart wants to write. I'm probably gonna put simplify, but you could put combine like terms. Okay, now this is where it gets kind of tricky, folks. I actually have to use line 3, 4 to get to 5. Okay, just feel me out for a second. I have DE plus EF here and DE plus EF here. So what do I know about these two things if they're both equal to the same thing?
So they're opposite.
They're equal.
EF.
PE plus EF equals
DE plus
What?
equals.
Oh, I just confused myself. What happened here?
You unsimplify.
I didn't unsimplify. 2DE.
DE plus
I get ahead of myself. Okay, let's erase. Reverse, reverse. Don't write what I wrote. Two DE, folks. What am I missing here?
Part D. Is it given again? It's just
No.
the same thing.
segment addition postulate.
Yeah, thank you so much. It is. Who said that?
Me.
Good job. You guys see DF is the whole segment. What two things make up DF?
DE plus EF.
Yeah, so that's segment addition. Perfect. Brownie points.
Brownie.
Save. You saved class. That was segment addition. I was one step ahead of myself. Segment addition.
It's 2D.
So now why can we say 2DE equals DF?
Because DE equals EF.
Because you prove.
This is what I was trying to get to. I was just a little step too early. You guys see how DE plus EF is repeated here? So now what two things are equal? If they're both equal to D.
DE EF.
Yeah. You guys see how these have to be equal because they're equal to the same thing? What property is that?
Symmetric.
Not symmetric. It's one that deals with three
The
things.
trans something.
Transitive.
Yup.
Think of it kind of like the law of syllogism. We're cutting out the middleman. Transitive.
Yeah, I was thinking
You're in the right
We're just gonna do one more, folks. So just hang tight. I know I'm probably boring you. One more to. Do you guys want to start this one on your own? See how it goes? Because you already know what number 1 is. You only have to try to think of 3 things. You just want to try it and see?
Given.
See, Gibbon's number 1.
Given a.
You're already 25% of the way there.
easy over here.
Maybe mark your picture.
Well, that one's easy too.
See if you can be a detective.
Definition of
through it.
Congruence. Shut up.
So I know it's one. What if you seriously did like a substitution?
No, it's not.
So what's happening between 1 and 2?
No, it's not.
What's different in
It's
those
transitive,
lines?
isn't it?
Maybe not. Somewhere even near that. That's wrong.
No, it's transitive, isn't it?
I don't know.
The third one's
What's number 4?
No, it's not.
Number 4?
It's transitive.
What is it? What is it?
I like 3, transitive or substitution.
That's what I was gonna say. Substitution.
Yeah, they can be used substitution and transitive to be used pretty much interchangeably for the most part.
The
Or when in doubt, I would probably just use substitution, but
put proof for the last one?
no, there's a reason for the fourth one.
No,
Was that the
because I'm
joy?
freaking done.
That was the big one,
You copied
TM.
my two.
Flex to do.
I didn't.
Did you guys get definition of congruence for 2?
Yep.
Okay, good.
Is the last one symmetric first?
No.
Last one is, I knew that.
What did you guys put for 3?
No.
Substitution.
Substitution or
Transitive.
transitive?
Oh, let's go. What about substitution?
Did anyone know for 4?
Yeah.
Yeah, look at the word. What word does it want you to use?
Midpoint.
So definition of a
Midpoint. Bet you didn't have that down, Matthew.
I did.
Yeah. Well, Matthew.
Are you gonna do
I
algebra
did.
for?
They did.
Oh, no.
Not even just.
I write that, but I haven't used it.
Do you guys want to do the last proof right now or tomorrow?
Tomorrow.
All right.
Now.